Solving systems of linear equations algebraically, first of all, if they give us a model type, we have to first go through and actually work through to get our model into an equation type format. So we're going to start by doing that, and then we're going to go through these steps that are on the left-hand side of the screen and show how we can actually solve a system of linear equations algebraically. So our first example here, we have a story problem. It says, a middle school yearbook committee has 35 members. There are 7 more boys than girls. Use the models to write a system of linear equations, and then solve the system to find the number of boys, which they're going to use X to represent, and the number of girls, Y. So as I look through this setup, I'm just going to shift this off to the side for a minute. I'm just going to take whatever's in each box and write it out with these symbols in between. So number of boys, X, because they didn't give us a number, plus the number of girls, Y, no number, so we'll just put a Y, equals, and then our 35. So there's our first equation, okay? Our second equation, we've got our number of girls, which is Y, and I'm just going to offset it just like they did in the model, equals the number of boys, which is X, plus 7. Okay, so there I have my 2 equations. Now, yesterday when we worked through to graph these, remember in order to graph these, we guys had to have them in our Y equals format. Well, today we're still going to do that. We're going to go ahead and isolate to get that Y by itself. So if I look at that first equation that's in red, I need to work to get that X out of there. So if I currently have this, let's see if I can shift this whole setup down. If I go through to try and solve and get Y by itself, I would do minus X to get rid of it. So then minus X. Now we are used to seeing that equation with the X in the first spot. So now I have Y equals negative X, and that's a positive 35. Okay, so I'm going to go ahead and get rid of this. And now we're going to look at these 2 equations. Okay, so the equations I have, we have Y on both sides, and here's how we're now going to go through and solve this algebraically. If those equations are both Y equals, that means that these 2 ends are equal to each other because they both equal Y. So when we go through to set this up, we're going to go ahead and write our equations. The first step, and I'll pull this step thing back out, is we need to solve both equations for one of the variables. So here we chose to solve for Y. Our second step is we're going to go ahead and set up the expressions as equal to each other. So that's what I'm going to do right now. And then we're going to solve for that variable. So we'll end up solving for X first. Then we're going to substitute back into one of our original equations to solve for the other variable. Okay, so we'll shift this up and I'll move this off to the side because we don't need to see that now. Okay, so the first step we did, we solved for Y. Our next step is to take each of these, and I'm a visual person, that's why I box around these. So we're going to take each of those boxes and write them with an equal sign between them, so a horizontal. So X plus 7 is equal to negative X plus 35. And it doesn't matter if you write it this way or if you had your negative X plus 35 is equal to X plus 7. That doesn't matter. You just have to put one equation on one side of the equal sign and the other on the other side. So now we're back to something that we did back in chapter 1 when we worked with X's on both sides of the equation. So we need to work, if we have X's on both sides, we always move the X's first. So we need to work to get our X's to one side. So if I have a positive and a negative, I always get rid of the negative. So we're going to go ahead and do plus, that's a 1x. So plus 1x. That's a 1 there too. So now I have 2x plus 7 equals 35. Let's see if I can extend my page here. Okay, so now I need to still work to get x by itself. So our next step would be then to get our non-x's out of there. So minus 7, minus 7. So now I have 2x equals 28. So now to get x by itself, we would divide by 2. divide by 2. So x equals 14. So in our system of equations, I'm going to shift back up to the top. We have our x and our y. So our x we just found out was 14. Okay, so now to find out what y is, we can substitute in that 14 into either of these two equations. It doesn't matter which one. Pick the one that you think would be easiest. So I'm going to pick this one right here. And I'm going to substitute in y equals 14, because that was our x, plus 7. So 14 plus 7 gives me 21. So I just found out that y equals 21. If I want to check myself, I could substitute in the other equation too. But remember, in this case, they were telling us a scenario. And the scenario was there were 7 more girls than boys. So yes, there was a difference of 7 there. And there were 35 students total. So we had 35 students. This was our boys, and this was our girls, since we were working a story problem, so that you know what x and y were representing. So that's what we're going to practice right now. We're going to go ahead and practice setting up our equations. If we have to, we'll get our y by itself, and then we'll go ahead and solve for x and for y. Erase the rest of this down here. Okay, so let's go ahead and pull out another equation. So here we go. We've got x plus y equals 27, and y equals x plus 3. So looking through our steps, our first step is solve so that both equations for one variable have one variable. So this one already has y equals. Let's work this equation to get it to say y equals. So right now I have x plus y equals 27. So we want to get it to say y equals, we have to get rid of our x. So minus x. Minus x. Okay, so when I rewrite it, I'm just going to write it below this one. I have y equals, put my x first, negative x, and that's a positive 27. Just in case I were to want to graph this. But here, right now, I'm going to explain to you why we wouldn't probably graph this one. Because if I were to graph the second equation, my graph does not go out to positive 27. So that's why we're learning another method. Sometimes you have scenarios where the numbers, and you have them, the graphs aren't big enough, and it's not practical to do a graph. It's not always practical to do a table. Solving it algebraically will always work, so it's another step that we can use. Okay, so now if I take both of my equations, now that they're in that format, we're going to take the back ends and write them as equal to each other. So I have x plus 3 is equal to negative 1x plus 27. And I'm going to put a 1 in front of that. Okay, so we've got x's on both sides. Our first step is to move the x's. So I'm going to get rid of the negative 1x. So plus 1x plus 1x. I now have 2x plus 3 equals 27. Okay, so now get rid of our non-x, move the what they call a constant number to the other side. So minus 3 is the opposite of a positive 3, minus 3. So I have 2x equals 27 minus 3 is 24. Now we would divide by 2. Divide by 2. I just found out that for my xy system, I have 24 divided by 2 is x equals 12. So my x is 12. Okay, so then my next step after I've solved for x is to substitute in. I'm going to pick to substitute in to this top equation. Why? Because to me, I don't like to work with negative numbers if I don't have to. So I'm going to take this 12 and plug it in right here. So when I rewrite this, it would be y equals 12 plus 3. So 12 plus 3 is 15. So I just found out that my x is 12 and my y is a 15. So my coordinate set was 12 comma 15. Once again, if I were to graph that, that wouldn't fit onto the graph that I have. Okay, so let's try another one. Okay, remember your steps. Always solve to get y by itself. So in this case, y is already by itself. So that makes it nice and easy because we can go ahead and just take the back half. And you'll notice in this one, see how it has 6 minus x? If I were going to graph that, that wouldn't work for me to graph it in that format. I would have to rearrange the x and the 6. And just remember that that negative has to stick with the 6. But if I'm solving it algebraically, I don't have to reorganize them. I can leave it as is. Okay, so I'm going to take the back half of each. So I have 2x plus 9. And then we're going to do is equal to, since they were both equal y's, 6 minus x. And I'm going to throw a 1 in front of that because I know that I'm shifting sides. Okay, so we're going to go ahead and get our x's to one side. So minus 1, I'm going to do a plus 1x. Plus 1x. And remember, it doesn't matter which x you move in most cases. It's just preference. If I have a negative over a positive, I'll get rid of the negative because I know when I go to the other side, it does the opposite. Okay, so now I've got 2 plus 1 is 3x plus 9 equals 6. So now I'm to a two-step equation. So now we have to get that 9 out of there because I want the x's on one side and the non-x's on the other. So minus 9, minus 9. 3x equals 6 minus 9. Those are integers. So different symbols, find the difference is 3. The larger number had a negative. So I get 3x equals negative 3. So now I'm going to divide by 3 to get x by itself. Divide by 3. So my x and my y. My x, negative 3 divided by 3, I just found out is negative 1. So I get negative 1 there. Okay, so now I'm going to plug into one of those sets. Doesn't matter which one. The one thing I will tell you is if you plug it into this one right here, remember that negative sign's already there. So I don't get to just substitute this negative 1 with that negative. I would have to write it out this way. Y equals 6 minus, and then plug in my x, which was negative 1. What's going to end up happening here? It becomes a plus sign. So 6 plus 1 is 7. If I want to double check myself, I can do that. I could go ahead and substitute into this equation. Because like I said, it doesn't matter which equation you choose. So if I were to do this one, it would be y equals 2 times x was negative 1 plus 9. So this I would get a negative 2 plus 9 is still going to give me positive 7. So it doesn't matter which equation you choose, you should still get the same solution to either of them. So our end answer on this would be negative 1 comma 7 would be the solution to our system of equations. All right, so I'm going to have you guys try one. I want you guys to try this one. So you're going to have to do this first step right here. And that is solve both equations for one of the variables. So this one's already set up with just y equals. You need to get this one so that it's just a y equals. So go ahead and pause your video and work your way through this system of equations, first starting with getting that y equals. So you should have ended up for your system of equations on this one x being 5 and y being -2. So 5 comma -2. And this would be one when I'm looking at the equations that you could actually graph. You'd have to remember, if you graphed it, that you would have to reverse these because your x is always in the front set. But when I'm solving it algebraically, I don't have to get the x in the first part. Okay, so this is working systems of the equation algebraically. Once again, it takes practice getting them to that point of the y equals. So we're going to do one more together, and this one's working with a decimal as well. So in both of these, we have both of them where we don't have the y by itself. So we're going to go ahead and shift and get rid of the x first on this one. So minus x minus 1x. Here's the thing on this one. Most common mistake is kids will forget about that negative, and we cannot have it as negative y equals. It has to just be y equals. So we could either decide to divide by -1. The other process that I like to use is if there's no number in front of it, it's the same as just doing the opposite to everything. So if I did the opposite of y here, negative y, that would be a positive y. If I did the opposite of +7, that would now become a -7. And if I did the opposite of a -1x, that would become a +1x or a +1x. So there's my first equation. My second equation, we're going to go ahead and get rid of this 0.5x by subtracting it. Okay, so now I have for my second equation, y equals 5 minus 0.5x. Now, if I was graphing it, I would have to write that with the x in the first position. I'm not graphing it out, so I can go ahead and leave it in the format that it is, and we're now going to go ahead and write these out as equal to each other. Okay, and if you want to use a calculator, you can use a calculator if you need to. If that just alleviates some of anxiety working with those decimals, that's okay. So I've got -7 plus 1x is equal to 5 minus 0.5x. Okay, first step, get our x's to one side. So I'm going to choose to get rid of this x by adding 0.5x. It's gone. So find my x's, which is right here, 0.5x. Remember, if you're doing this longhand, you line up at the decimal. 1 plus 0.5 is going to give me 1.5x. And then I still have, that's a plus sign in the front, a -7, and an equals 5. Okay, so now I want to get my non-x's to the other side, so I have to move this 7, plus 7, plus 7. I get 1.5x equals 12. Okay, so now I need to get that x by itself. Okay, and this is where I'm saying I'm not checking your longhand division of 1.12 divided by 1.5. You can go ahead and use a calculator. So divide by 1.5. Divide by 1.5. And when I take 12 divided by 1.5, that's going to give me 8. So I just found out that x equals 8. So it's going to be 8 comma something. So final step is to substitute in. Now, if you don't like decimals, I wouldn't substitute into this equation. So I'm going to go ahead and substitute into this one. So I have y equals -7 times, plus 1. -7 plus 1 times 8. So ultimately that becomes an 8. 7 plus 8 gives me 15 for my y. My solution is 8 comma 15. Okay, so that's it for this lesson. So once again, let's review those steps. Your first step is to solve both equations for one of the variables. I highly recommend doing y equals, but if you wanted to do the x equals, you could. Your second step is to make sure that you write out the expression so that the back half of each of your equations is equal to each other. Your third step, then you have to solve for that variable. So if you have x's on both sides, remember to get x to the one side and the non-x's to the other. And then your third step is once you find that first variable, we always worked and found x first, you're going to substitute back into one of your original equations and solve for the second variable. So in our case, we always solved for y second. Make sure that when you're giving your answers, you're writing them out as your sets of coordinates, so your x comma y. And that's pretty much it. These just take practice, but I promise if you practice them, pretty soon they become really easy. The only new step is that showing those equations, because we have worked to get y by itself before. We've also worked to get x's on one side of the equation before. So the new step is just setting it up into this format that we have right here, where one equation is equal to the other. And then the final step was getting that x and y, writing them out as a set of coordinates. So good luck with this one.